The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dan DuPont of HawaiiTracker.com, bringing you guys another Hawaiian Volcano Tracker update. Today is Thursday, February 2nd, 2023. Only minor changes on Kilauea. Mauna Loa is still quiet, cooling. We'll talk about the minor changes on Kilauea Day in this week. With the major event that happened in the last 48 hours here was a little waning of the lava lake, just playing on the screen here, and the return of the lava shortly thereafter, corresponding to a deflation-inflation event. How have you been this week? Oh, today is not the day.
Yeah, been doing good. Been doing good. It's really interesting just to see this waning and then reactivation of activity. And I'm sure we'll be able to discuss some of that and what it might mean here in a little bit. We'll lead into it. But yeah, it was really dramatic, waking up and being like, all right, well, let's check the camera and see what happened. Oh, wow, we have action right up there last night. So yeah, we'll go over that and go over the recent activity and everything and maybe touch on Mauna Loa a little bit as well.
Yeah, for sure. Yeah, and there have been a lot of community events happening. We just finished up Volcano Awareness Month a couple of days ago with a stream from Two Pineapples up in the park, Kilauea update. So we're past Volcano Awareness Month now into February. We won't have as many of those talks, but we'll have plenty to talk about to follow up on those as the month goes on.
Yeah. Yeah, I mean, there was some great events, and maybe we'll recap a little bit at the very end about some of the Resilience Hub things that were going on.
yeah, Resilience Hub. There's Activate Puna this weekend, so we'll cover the community calendar here at the end too as well.
Right.
But that being said, we'll start to get into it here. If anyone watching has any issues with their audio or video, let Dane know. He'll be leading discussion in the chat, collecting questions. We'll discuss things as we go. Anything else, Dane, before we get into it?
No, I think that sums it up. Let's go on and get into it.
All right, so here's our Hawaiian volcano summary for the week. What you guys are seeing here is this loop from the S1 camera on Kilauea, showing that interval of the lava lake waning and then refilling and rejoining, right? When it actually is waning there, you see it separates into two distinct bodies, two separate little ponds within that lake. Then it refills and restores itself to what it was before. So that's the short visual of what Kilauea has been like this past week. We can also look at this through the thermal image here, and I have plotted on here at the on the bottom left, very bottom left, back in here, the tilt plot showing deflation-inflation. You can really see how the very end here, when the volcano starts to deflate, that's when the lava actually recedes right there, and then when it reinflates is when we have this surge back of lava that floods the area. And the lava depth the entire time has been rising, so it's collecting beneath the crust and filling the lake, and just showing a slight fluctuation here at the surface corresponding to that deflation-inflation event. I also have the tremor here on the bottom right, because it looks like you can see for the first time we see the central pit has actually been overflowing. It does seem to correspond to some of these tremor bursts that we see on the instruments here. So we'll dive into that a little bit more in our longer update here, but just to check in on a live camera on Kilauea, there it is, still erupting. You don't see it moving nearly as much in the live view, but it is moving, of course, sometimes more than others. So we'll get into that here a little bit as well. On Mauna Loa, our summary is captured by this graph, which is the plot of distance across the caldera north to south on Mauna Loa. And you see this pattern that where it was expanding, slowly building up to the eruption. During eruption at the end of 2022, it jumped up and then quickly started contracting. And then as the eruption was ending, before it actually stopped, we saw the turnaround of that signal with the caldera starting to extend again and coming upwards. So it looks like that might be, if we zoom in, we're right way down here to the right, that may be starting to flatten a little bit, perhaps temporarily. But this is all expected within a larger pattern of the volcano. And so as just a brief teaser, I thought I would pull out this plot from 74 to 85, showing the 1984 sequence here. So you actually can see very similar. We had a long, slow buildup. The eruption comes up, recedes, and actually then shortly thereafter flattens out briefly. Slightly different time scale here. It seems like ours is happening a little bit at an accelerated pace, but the pattern fits, and that is expected, and therefore there's nothing unusual happening on Mauna Loa. So that's the short summary there. We'll get into the details more now, starting with monitoring of Kilauea. So that's what we will flip to here. Starting with this 1 week plot of the lava depth here at the top, which I had scrolling in that one of those last videos here. But you really can see in static form here for the week. Started off at 386.2 meters, and here it ends at 387.4. 1.2 meters is about 4 feet that it's gained during this time over the last week here. You can see it did it a little bit more quickly in the midweek, and more recently, corresponding to that deflation-inflation phase, it seems to be a little bit flatter here. Now, it's worth noting that this laser line that we're looking at during that deflation-inflation event isn't varying that much. It's only varying in an order of 0.2 meters, right? So this, to me, does indicate that this laser level is pointing to that western lake still, and not the one we just saw divide into two and rejoin itself, right? Otherwise, we should have seen potentially a more dramatic drop in the lake depth and resumption as well. Similar to what we were seeing earlier, when was it? End of 2021, I believe, Dane, when we were seeing beginning of 2022, when we saw those big deflation-inflation events and corresponding drops in lava level too. So it looks like this is still pointing to that western side, which is showing more of the whole rise of the whole crater floor all at once, right? Rather than the small variations within that eastern lake. So the whole surface still is rising. You can see it rose about 4 feet there. And that is despite the tilt for the last week, shown on this next plot down, showing overall a week-long decline. You can see some little variations, deflation, inflation events. Here's a large one we just saw that corresponded to that waning of the eastern lake. And a resumption here just occurring overnight last night. And zooming out for the last month, here is lava depth. So since eruption began just under a month ago, we're actually getting to see this is the best these month plots are going to look. We catch the beginning of the eruption right here with that big flood of lava filling that first almost 10 meters, 30 feet of depth, and then rising more slowly since then, right? It's actually come up, it looks like another, not quite 10 meters there, right? Maybe call it, oh, let's see, yeah, somewhere around there, another 10 meters, 30 feet or so, more or less, since that beginning phase there. Just very roughly here, I'm not going to zoom into it, do the math there. So for the last month of tilt, you can see there is a beginning of eruption there with that large spike earthquake that preceded it, change in the ground, release of that initial pressure. And we see lots of these deflation-inflation events stacked in here. And you can see there were 3 in that first week and 2 in that following week and 2 small ones and 2 medium ones that following week. But really this most recent week that we have here, we've had no deflation-inflation events until the most recent one now, right? That's another thing to point out up here. In this week-long plot, just one deflation-inflation event that's of this larger magnitude. So that's interesting to note that the events seem to have slowed down, and not only that, when occurring now, they seem to be dramatically affecting that eastern lake surface. That could last for a while. We saw that be the case with the western lake earlier last year, but after a while, that phase did end, and it then resumed its previous activity of showing deflation-inflation underground without having as much expression at the surface. So, as usual, wait and see what happens there. Just trying to recap some of the previous events in case anyone does not recall here. So there's a month-long tail to deflation-inflation events, and you really can see this pattern more clearly of this long deflationary drop, right? So the volcano is still relieving pressure, the lava is still getting out, the very surface, there's funny things happening, but it's all leaving the underground area towards the surface efficiently enough to allow the volcano to deflate and essentially sag back inwards underground, right? Over the last month, earthquakes were high just prior to the eruption, but have been steadily low since then, with a few small variations through here. And likewise, the gas started off at the highest values reported of 12,500 tons per day and dropped down to below 4,000 tons per day and are now around 3,000 tons per day at last report. And that's also following that same pattern as expected there. We'll zoom out a little more. Here is the whole last year. So earthquakes during that previous 2022 eruption of Kilauea that was ongoing until December, really, and then followed by that hiatus that was induced by Mauna Loa, build up an eruption there and then relief of eruption, followed by there's the earthquake build up on Kilauea, and then here we are in this most recent phase of eruption, back to these levels that we saw prior. So all good there. Summit SO2. Here is our spike from the low value. So, the last eruption was kind of tailing off, as it typically does. Then there's our spike, and now we think it would probably be tailing off more like that as well, right, into the future, following that same pattern. And interestingly, that Summit GPS, which is one I always like to look at, in that same time scale right here on the right. I'm going to zoom it in. Maybe, there it is also showing contraction. This is also similar to that teaser Mauna Loa plot, where we're looking at caldera distance north to south, which was expanding during a whole previous eruption for much of the time, and then now has been still contracting. And at some point, this will turn around, will show us that the pattern returns to what it was before. But for now, it's still efficiently getting material out towards the surface. That's what this is telling us. Consistent to the GPS and the tilt here as well. To finish it off here with monitoring, here is GPS on Pu'o'o and the upper Middle East Rift Zone. And it's still showing contraction all the way down. Some minor changes. If we were to look at that same period here in Pu'o'o, you might think that maybe it's slowed down a little bit. It seems to be still decline, but it's a little bit flatter, right, than it was previously over here. But as you might notice, there have been previous periods that have also had this lack of drop, right? So we'll just have to wait and see what's going on there. But it's not really clear that there's any response on that rift zone that we can tell, and USGS certainly is not reporting any. So that's the monitoring data for the week, and I just wanted to finish us off with our source here. This is the HVO daily update from the USGS. This is today's update. These are coming out daily, of course. And today's offers a little bit more information about that event that happened in the last 48 hours here. They do note that the eruption continues and no significant changes observed, right? Observations of the lava lake itself, they do note here, activity in a large eastern lava lake began to crust over yesterday morning and formed an isthmus of crust through the center of the lake with two smaller patches of lava on the north and south sides by yesterday afternoon. Combined, the two active areas in the eastern lake were roughly half of the 25-acre size measured on January 17th, and each showed independent and opposite surface convection directions from the levees towards the isthmus, former center of the lake. Just note, we'll talk about that here in a bit as well. The lava fountain in the eastern lake, southern part, disappeared for roughly 45 minutes at 11:15 p.m. Hawaiian time last night, but returned by midnight. By 1 a.m., the lava surface from the southern part of the eastern lake was flooding across the total eastern lake area bounded by levees, covering the lava crust isthmus and returning to most of the original 25-acre size by 4 a.m. this morning. The eastern lake remains stable and has returned to a single lake surface at the time of this post, and the smaller western lake, as well as the two smaller lava ponds, remained unchanged through all this activity yesterday. However, one of the smaller ponds closest to the eastern lake, that's the one I'm calling the central pit here, produced an overflow during the 30 minutes prior to this post. Live stream available, SO2 still 3000, no changes in the rift zone, hazards are still, as we've described, primarily the gas there. And so that's the source, and we have a little bit of description, a little bit more than we usually get, a little bit more verbose than we usually get about that change, and so we'll dive into that pattern over the last week here next. So let me switch my heading here to our observations, our practice of Kilauea. So, and here we have the whole last week from the KW camera. And last week we were noting that we had overflows, not overflows, but ooze-ups from the perimeter of the lava lake. There was one there, and there was an earlier one that occurs down here in this eastern segment. Let me start it over since I want you to see that. Here's the eastern segment coming up. There it is in daytime. And that, I should say, this is the southwest. I don't know why I'm calling it the eastern. The southwest segment over here, and then the northern segment back up in here as well. There are the two that were showing ooze-up flows. The southwest one seems to die off within that first day, it seems. You do see some glow and some puddling there. But this this northern one does appear to be persistent for a few days, and you have a second northern, maybe a northwest ooze-up flow coming up. Not as big as that first northern one here, but still occurring early in the week and actually still occurring today. So it does seem like lava is still filling beneath this crust more so than can be accommodated by the output of the lava lake itself. So it's still trying to lift that crust up and oozing up the edges in this case on this northwest edge, and earlier last week it was also at the same time in the southwest edge there. So that's what it looked like for the whole week, and then all the minor changes we're talking about occurred within that lake surface right in there. So I have blown this up and taken out the daytime frames so you can see a little bit better what that change actually looks like. So note that this western pit lake remains continuously active the entire time, as does its southeast pit. It's here in the background, this eastern lake that we see most of the change, and then a central pit that also is overflowing there. So this is just quickly clipped from the overnight frames here. You almost see what looks like a swirling motion, but I think it's just the angle of what you see here. We'll show you different cameras, and doesn't have that effect on any other views. But what is noteworthy that we talked about, the USGS update mentions that isthmus, this gap, this separation appearing right through here. And we're still having lava come up in both areas, right? So it does certainly indicate there's more than one upwelling source. Lava's coming up in more than one area. It's clearly coming up where the fountain's bursting through the lake right in there. But it also seems to be coming up, at least recently, out of this further northeast margin of the levee lake as well. And so that's really interesting to note. And of course, it's also coming up through that central pit right in there. So a little bit more breakdown here. Let's look at the F1 camera. So this is similar. There's an ooze-up flow and that western edge, the bottom of this picture here. And through here, we see that main change in the lava lake, the waning and resumption of the flow there. And you can note there is an overflow in the middle, western pit, and it's associated southeastern pit, steady, and they're in the background. A little bit harder to see, so I'll blow it up once again and play this version where you can see the lava depth rising. Consider that the surrounding crater crust. And then the deflation and inflation. When I'm scrolling this, really this right edge of the plot that you need to worry about is what it's actually showing on screen, and the very bottom of this one right through here. So you note there's one of those tremor bursts comes through, and you note that overflow of the central pit occurs at the same time. And quite often these tremor bursts are associated with extra movement of fluid through the ground. So in this case, it's hard to know exactly, but one reasonable idea would be that there's extra large volumes of gas coming out during these times. And as they're moving through the system, they're creating extra vibrations and causing extra tremor. And when it comes towards the surface, they're causing that lava to be lifted up and out of the pit and overflow the area as the gas is released, and then essentially have burped the volcano and gotten your job done of relieving the gas pressure. So that's really interesting to see. I thought I'd play this one more time because you can see earlier in the week we have one of these tremor bursts. We don't have an overflow right to that point in time, right? And then here's another tremor burst. We have overflows of the main lake, but not of the central pit. Lava lake is still inflating, or still filling from below. There is a burst from the central pit, right? And there's another one. And you can note that this is happening even before the deflation starts. Once the deflation starts, you don't see those overflows, but once the flow resumes in the main lake, then after a short delay, you see the overflow from that central pit again. So really interesting to note and consider what these dynamics might be underground, even very shallow underground underneath this crust. Hard to pin exactly what's going on there. And this is a kind of measurement that we saw Jagger and his associates 100 years ago describing, like where the lava was coming up, where it was going down, how the islands were drifting, all those things, trying to figure out the dynamics of the lake. And it's always very hard to nail down, and it can also just change any single day as well. So that's the game they're playing here. So I'll play it one more time, just so you can note, the areas where lava's coming up, where it's going down. Right, we know that it was going down in the center during that low time. So coming up from the sides there and here, and going down in the middle, but also moving underground through that crust to that western pit that's off the screen here as well. So there's that isthmus. There's a flood from that main lake, and then secondarily the flood from the central pit. So I don't have any real good explanation answers for like the timing and sequence there, right? It does seem like the original lava fountains came up through the central pit area. So you might consider that there's still an opening down, like a fissure still deep down beneath this area where maybe gas could come up efficiently straight up. Gas doesn't like to really take any major bends, right? So it's going to try to come up straight up, and maybe that's happening through here to cause that gas burst to be more visible. But clearly there's also at least a multiple pathway where it's able to get to this other lake as well, right? So it's really confusing, but interesting to note the patterns and the timings there. All right, let's do a different view of this. Here's an S1 camera, and there's a few things to note here. Let's just let it play through for the whole last week here. Nighttime and daytime. We have a persistent fountain here on this southern end. We're now looking from south to north. North would be more or less that way. You see all these little islets floating around in the lake. You see that this one is drifting from the edge towards the center. We'll look at that here shortly. And there, the lava level seems to recede. Here's our isthmus, formed by this core of islets that are frozen in there, and then resumes again. So I'll play it one more time from the beginning. Let's focus to start here on this perimeter in the northwest. Right, you see this big peninsula. It's like sticking into the lake, breaks away, forms this largest island there. It actually breaks again, so it's forming two of these islands. See, the lake wants to have more of this round shape rather than having any big indents in it. So there is those blocks. They drift across. They seem to be pulled towards an area right in here. They're kind of all gathering right in here for some reason, right? And this is an area that we know as the lava recedes, the USGS believes that this is where the lava is draining down into. So maybe there's a downwelling underneath there. Maybe that's the circulation. And tricky because you can have currents at various levels within a lava lake. So that at the surface, you can have a current going one way, and then just below that, you can have the current going in the opposite direction. You can have multiple layers in there, and it's hard to really tell what's going on unless you have these tracers, right? So We have those islets, they drift around, but we don't know how deep each one of them is. If they're deeper, they might be caught by the deeper currents and move maybe towards the fountain, maybe in the opposite direction as of other ones, and the ones that are shallower might just move right into surface currents as well. So that's some of the factors that might contribute to that. I thought I would loop just this one section of the S1 camera. So you can see that here's a gas source in the northeast pit, right? And it seems like that seems to be where the lava is coming out from there and filling this area. And obviously the one on the south is easier to note from the fountain that pokes through the lake surface there. It's interesting stuff. You can see all these islands now seem to have been welded to that hardened isthmus that seems to emerge from the lake there. And we'll have to wait and see if they'll keep drifting around, if they'll refloat, or what exactly will happen there. But those are some of the minor changes that are interesting to consider as a scientist here. So that's the S1. We have the V1 camera, right? And this is actually something Dane and Lou from Two Pineapple was put together here, showing really fast that surge of lava that burst through from that V1 camera from that southern vent of that eastern lake. So this camera is pretty zoomed in. You can't see the secondary, that other second half that's in the north. You can't see the isthmus. You can't see any of that other stuff. So we just focused on the refilling of the lake here. So real quickly, you can see that extent lava coming out, surging forward more quickly. You can see that islet next to the vent seems to be pretty well parked there. And there it is, a huge flood of lava, spectacular views in the national park for those who were able to see the activity, whether it's this phase of it or any of the other stuff that's been happening. Always something interesting going on up there. So one last view here is the B1 camera. This is looking from the east towards the west, and north would be more this way now. And we see some of the overflows early on in the week up there. And then I'll focus in during the lava lake itself. You can see those islands moving around a little bit in between all the flickering, but there you can see them floating around. It's not the best angle, but you get a little bit more of a low angle. You can see the profile, the edge of this crack when the lava level is higher and lower there, which I think is interesting. So yeah, there was that. We can check in on the webcams presently and just make sure, as we did last week, that there is nothing new occurring here. We don't see any new ooze-ups occurring. It seems like everything is on track as we just described. There is a thermal image presently showing, and it looks like the lava lake may be slowing down a little bit back here in the east again. It seems like you do see not quite as bright in this section right through here, right? So it's interesting. It looks like maybe more of a crust forming right through there. It seems to be more active on that northern edge. So interesting. That's a small minor change there. We'll have to wait, and we might see further changes of strength from this southern fountain, and maybe this vent over here in the northeast becomes more active. Interesting to track what's going on here, but still in progress, and we'll have to wait to see what comes next. Right, there is our V1 camera, and as we just noted, this is that section that's looking more stagnant all through here. S1, you can still see the fountain coming up, and B1 looking low angle across the crater there. So those are the webcam views. We have some more visual observations we can bring you. This is from USGS releases of photographs. This first batch from the 26th. Focusing in on the edge of the lake, here's a lava overflowing the levee. That the levee being in this darker area right through here. The silvery stuff in the back is a liquid lake with its crust. And then this is the hardened solid lava over here. It's a little bit darker color, and the lava is flowing out through this little breach in that gap. So closer in, there's a little bit of the fountain, one of these small islets. And dusk views, similar. You really see that higher profile of the levee during this lower light here. So pretty interesting, and there's a wider angle view. And I just want to bring this one up as well because January 20th, this was now 2 weeks ago. You can see a much different distribution of the islets, right? It's interesting to know how they're drifting and migrating around in time. Okay, here's a couple interesting ones. Close-up of Lava Lake Levee, the summit of Kilauea. The levees formed by numerous small crustal plates rafted atop one another and fused together. A photo by Matt Patrick. So this is one I thought I would zoom into. There is a zoomed in view. There is an edge of the lava. There is these plates. Right? Maybe you can get a better view there. And there are all these different little slabs of crust that are all separate, stacked on one another. And you see things like this silvery flow. It's lava that's been oozing in between these areas and fusing them together, and also just covering the whole mass with another layer that's more coherent, and that's how it grows and builds its height, and also why it's brittle enough that when a lava level gets a certain height, it'll just fail in certain places and allow the overflows to occur. So that's what the levee actually is there, and there's one more image of that. Here it is, in a different view of those plates of crust there. And here you get a little bit of the idea of how this actually happens. Right, there's a lava flow right through here. It's forming this skin of little plates of crust on the outside. They flow, and these basically get pushed to the edge here. You see them piling up even right to the area right through here. A little deeper dive into that aspect of it here, but we'll move on. Let's see. Move on to. Oh, there was one more image of the bubbling and that islet there in the middle from that release on the 26th. So moving on to the release of the 27th from the USGS. They're noting another picture of the islet, steady activity. There is that little dome fountain in the lake bursting through. By this point in time, nothing had really waned, so appropriate for the time. Here's a geologist using a laser rangefinder to measure the surfaces in that eastern lake clearly at this point in time. I'll be curious to see what the reports are for that eastern lake compared to the western one, but cool to see them doing it. And here is that view that we more typically see from that western ridge of the western rim of the caldera, the KW camera view. A little bit better resolution, showing the whole landscape there, right? So that eastern largest lake that remains, the central pit lake right through there. This western pit, as I've been calling it, from that original eruption 2022, and it also has a southeast pit, which is not glowing in this image, just right through here, that attaches through a little passageway right through there, just off screen. And at the very bottom, west vent complex of the 2021 to 22 eruption. So that's the release from the 27th. There is one more. That's January 31st release here, and they're showing some of the variations. So here's that dome fountain just before one of those bigger bursts, where the surface is actually sagging down. It's almost even with the surface there. And you can see the lava level is pretty high. This little islet that's just off to the side here is showing very little profile. It's not sticking up above the lava level very far. See, that's different at some points in time. Then here, showing a clustering of those islands in the background there. So there's a wider angle view and a zoomed in view here. And these are two more that I thought I would enhance a little bit. So there is that dome fountain, that closer islet, and there is this cluster of islets that are gathering prior to the waning of the lake right through here. And if we go to that zoomed in version, there it is, and you can go a little further, you can actually see that despite these being small features in that wide angle view, they actually do have some height to them sticking above the lava level here. There's that hardened crust. You see just the cracks in that crust of the lava peeking through when a level is not as active. So it may have been starting to wane already by this point in time when this image was taken. So that's two of the images there. And then we also have this one, which is zoomed in into that central pit, and you can clearly see where it's had its largest overflow over here to the east, but also all this area that's lighter colored is all overflow from the recent activity of this central pit area right through there. This one, I'm going to zoom it in, is actually focused in on the Kīlauea, the white-tailed tropic bird that likes to live in the crater walls. So there it is. It's long tail feathers, and it's flying all across the caldera landscape here. And it looks like Matt Patrick caught this tropic bird as it was flying first over the central pit. There it is. And then also flying over the dome fountain, there is the bird once again right there. Bird again, once again right there. And then he's looking at the levee edge, photographing that, and then he catches a bird one more time. So we'll end our imagery here with this series of the Kīlauea with various volcanic features in the background here. So that's the visual observations. Actually, there's one last one I'm going to bring up here. And this is a post from Andrew McGinnis on Hawaii Tracker, who caught the USGS Lava Lake livestream. And let's see here. Zoom in this way. So we have the spot where the crust is breaking. And the gas is being released through the crust, and it's breaking the crust, allowing the lava to be thrown out by the gas. And depending on the surrounding dynamics of the atmosphere right around there, I'm not a meteorologist, so I can't tell you much more than that, but there is that release of gas causing a little whirlwind and throwing bits of lava further out across the crust. He's also starting this foundering process. You see the crust starting to break apart a little bit. Starts expanding a little bit over this direction over here. And pretty cool little mini feature. There it is. Picking up momentum. So lots of cool things to see. These minor changes on the surface. None of this is really changing the dynamics of the volcano. There's no larger threat to anyone living around, whether it's in the Lower East Rift. There's a nice big chunk of crust got flung up right there. Some more big ones getting tossed up there. See, they land, they break the crust. In any case, minor changes, nothing to worry about for people. It's really, this is the best time to go and view the volcano. It's really the glory days of viewing right now, if you're able to go and check this out in person. And if not, then plenty of views like this in a live webcam and time lapses, which people from afar can watch and capture and share, as Andrew has here. Mahalo for that, Andrew. Appreciate you. Pretty cool. I think I'll stop it there. If you really need to see the last few seconds of the last chunks of crust, I'll urge you to go on Hawaii Tracker and look that up there. So that's the viewing. If you are going to go and view in person, do check the Hawaiʻi Volcanoes National Park website, because they are putting advisories on there, such as expecting delays and limited parking due to high visitation. Good times to visit. They also have a map on here, which we'll look at in a second. Different views, nighttime and daytime, from different angles there, of what you might be able to see, distances you might have to walk, all of that. So definitely worth checking out if you're not familiar with the area. Looking at the map though, today we'll just focus on one small clip by two pineapples taken from Uikahuna, right in here, looking at the lava lake in this direction there. And there are also sites at Kupinaipali and Kanakakoi, right, that we've covered in the past. But for today, we'll just focus on this contribution by two pineapples, zoomed into some of these interplate spattering of the lava lake there, right? So you can see it's really zoomed in. I'm going to zoom it back out there. You can see how this is occurring down in the middle of the crust of the lava lake, away from the larger fountain that you see there on the right. So still epic views, great viewing. Go check it out if you possibly can. This is an area that's a good distance away, so it definitely helps if you want to see this closer in things to bring a binocular or large camera lens, telescope, that kind of thing. It also does mean that for the most part you are able to escape the gases. However, the gases have been an issue recently, and we'll turn to that next here. Something to always keep an eye on, changing day to day, and sometimes hour to hour, to be honest there. So looking at the VOG mapping project, VMAP product here, we have our source of Kilauea, and this orange stuff is the probability of exceedance of moderate threshold of SO2 there. And since SO2 is always, as I usually show that, SO4 shows a bit more of the particulate VOG as well. So you can see it affecting more of the Kona coast there than the actual pure SO2. And the wind right now for the next couple of days looks like it's more of our normal trade winds, but over the last week it really has been all over the place, and there's been fog just about everywhere in this southern 2/3 of the island here that I've been able to tell. But since we were talking about the park first, let's check in with them. Last week our plots were not very pretty for the national park. Today, at the moment, they're all green. And if we actually go to the charts that document the history at each site, you'll see that they've been in the green all day today, in fact. And it's not always the case, but definitely worth checking. You know, even when a fog is blowing around, sometimes that closest place at the viewing area is totally in the clear, believe it or not. Sometimes even when it's been pouring rain, I've gone up to the viewing area and been able to get a view looking down into the crater without having any rain or fog in the way. So it's almost always worth going up to check it out in person, even if it doesn't look promising, is my personal opinion there. But since the fog is the largest impact, do be aware of that. And of course, near the volcano presently, it's at green and 0, and further in Kona, you see all those higher measurements from that particular matter. However, like I was saying, it's coming and going. So here is our plot in the volcano area, and you do note that it did reach into the orange yesterday, and it's been in the yellow just about every day this past week here. And so that's the volcano area. We go down to Pahala. It typically looks like that as well. 0 presently, but let it load and you can see it did on the 31st, a couple days ago, peek into that orange and has been in the yellow several times as well, almost on a daily basis too. All right, let's move over to Kona side. We'll just go somewhere here in Kīlauea, Kona. And you can see there that PM 2.1, there it is, hitting the yellow. Not getting to the yellow very much, but certainly bouncing around. It certainly has been elevated off and on depending on the weather conditions there. So that is Kona side. Let's finish it off with a couple on the east side. Hilo even getting into the yellow a couple of times here. Right? And usually most directly upwind of Kilauea is Pahoa. And Pahoa you can see in the green the entire time, but actually getting kind of close to the yellow a couple of times. So if you happen to be in a Pahoa Lower East Rift area and did smell some extra gas this past week, there is a decent chance that it could have been coming from further away as well. So I haven't heard many reports of that, but if there are anyone out there that's saying that, then
I have seen reports of that. Yeah, I have actually, from the people that are we figured out in basically 2018 that they have a higher sensitivity to the SO2 than say you or me. And they were talking about being able to smell fog and, symptoms of fog and stuff like that within the past week.
Well, thanks, Dane. Thanks for that first-hand info there. And there is a plot that's backing it up there, right? So, yeah, it's been all around. Be aware of that as your primary hazard of this eruption, right? And you can go look up the VOG dashboard if you really need more information about any aspect of VOG, health conditions, implications, any of that. So that is the gas. We will move on from gas to earthquakes. Earthquakes have been pretty quiet, as we mentioned before. Here's Kilauea once again, but in map form over the last week. A few spattering earthquakes around the summit. South flank, background as usual. Pahala, continuing as usual. Nothing really worth discussing there. That's abnormal. For the last month, you see a little bit fuller picture because we're catching the whole eruption startup sequence there. But there's really not much else to share for the earthquakes here. We can go to the larger map. There's a Pahala cluster. There's Kilauea summit and south flank. Mauna Loa has a couple events. 2.2. There's a 2.3. But overall, not enough to be concerned. It's likely just the adjustment and settling of the mountain following that eruption that occurred from more or less in here. So that's the earthquake pattern. And a few other background events across the island, surrounding the island as well. But the largest events this last week were magnitude 3s down in a deep Pahala zone back through here. So really the largest 4 this week, 3.3, 3.1, 2.9, 2.8, all in Pahala, all deep down. So really it's been pretty low activity overall. So that is earthquakes. We will touch base here on Mauna Loa. Right, Mauna Loa, I just mentioned the earthquakes have been down. You can show that another way. You can look at the monitoring signals. Here's a topo for the last week. Can't see a whole lot. Still looks like it's rising a bit, but in comparison to the last month here, you do note that that rise that we noted last week that seemed to be a little bit steeper seems to have shallowed out a little bit again. So it's not clear if this is part of some larger Earth cycle here, like a tidal cycle or something like that, right? But it does appear that it's mirrored in the GPS, as we mentioned earlier at the start of the program. It does appear to be possibly turning over there as well, right? Showing a slight pause on the inflation, perhaps, or it's a little slowdown. The pattern is, this is all normal for Mauna Loa. It's something we've seen on Kilauea. It starts to inflate even during eruption, while more magma is coming in and can get out. So magma is coming into Mauna Loa once again. The volcano is still alive and well. She did just erupt. She has to recover, but she recovers by refilling with magma, and that's what's happening here. So refilling. This is the north-south distance and just a straight up measurement. So both very similar patterns. Earthquakes for the last week, not a lot. You see some background events here, hardly visible on the screen probably. For the last month, a little bit more, but still not a whole lot compared to before, right? And if we look at the actual earthquake rates, really random, with at most 10 per day over the whole last month here. So really not a lot. For the last year, you can see earthquakes per week now. Eruption peaked at over 400 earthquakes that week prior. And now we're down in this range of 20 to 30, or really the background value or so, right through there. Right. Zooming out a little further, here's a 5-year earthquakes build up to the eruption this months ahead of time, and then a drop off. Here we are in the post-eruption phase. GPS similar. We're just showing a lot more of this build up that comes prior to this event that occurs here within the last 2.5 months. So north and south, and then up once again as well. So I mentioned last week that, we did talk about this earlier as well. So there's the similar measurement of change at the summit. This is going back to catch the 75 eruption here, and an 84 eruption. And so the 84 eruption was the northeast flank eruption, which is the more similar one right through there. Right. So that's why if I'm going to focus on a piece of this is the part that I'm looking at. You can see that similar pattern. Right? Really, if you look this point right through here, probably corresponds to the beginning of 85. So it may have taken us, we don't have quite the resolution here. There's a gap in data right through there as well, so you don't exactly know, right? But it looks like it could have been a few months further along after the end of the 84 eruption that they had that little hiatus. Whereas we're happening a little quicker now. I'm not quite clear what the implication of that actually is. It's just interesting to note that they have the same pattern, but slightly different timescales so far. As the monitoring comes in over the next months, we'll have a better picture of comparing this and knowing what's happening as far as the rebuilding towards the next eruption, which will happen someday as well. So last week we mentioned taking that GPS plot for the last year or 5 years and matching it to this previous pattern. So here it is. This is actually 5 years right there on the top right, which we note the distance down here at the bottom. That's 5 years is also what you get there. So it's a little bit different. The ink's a little skewed, right? But you see when you have these eruptions, you have a large extension. And 75, this was summit eruption, and not quite clear if there's not as good a resolution, but you almost expect there to be a spike here as well, and then a drop down, which you don't see. And it resumes, and you see climbs rapidly, little lull, climbs rapidly, little lull. They're climbing for the eruption of 84, drops off, climbing rapidly, little lull, climbing more. And that's the same pattern you see here. Joining straight up and coming back down. And now here we are. Actually, no, that's not quite right. Let me zoom it in and draw it better than that. So coming up, then down, and then back up. Here we are, somewhere in there like that. We'll get a prettier version of this, I'm sure, at some point, but this is the first-hand, just quick Photoshop attempt at what it might look like in the future here. So that's the Mauna Loa data. We'll tie it off here with the USGS update from Mauna Loa from today. Not erupting, no active lava, no changes, cooling no longer active, no tremor, no SO2. Everything is just like the last week. And here is the official backup source for that. So that is Mauna Loa. A couple of final things here community-wise. The first is the set of Volcano Watch articles. Since we missed the one last week, we'll mention it as well. Last week's article was Kilauea gets weighed in. And this is an article talking about the ongoing, well, might have just ended, field survey of gravity on Kilauea. And you can go and find us on hawaiitracker.com if you want more details about the actual survey details there. But they're going around and doing measurements across all of Kilauea Summit. It does say here over the month of January, which is why it may have just ended, a 3-person team comprised of HVO geophysicist Ashton Flinders, University of Wisconsin, Madison PhD candidate Claire Ruggles, and UW student Sophia Thompson will measure gravity at over 400 locations around Kilauea Summit. Their Bugre gravity survey will be the first to address significant large-scale changes associated with the 2018 caldera collapse. So that is the gravity survey article, right? And they are going to combine that data with all the other surveys they have going on, including their 2023 anticipated Kilauea Summit seismic study as well. So that's something that we mentioned, I don't know, a couple weeks ago, a week ago, about how there's another deployment of seismic instruments that they're going to put across the summit, kind of following up on a Hopahala exercise data collection that was done last year. So more seismic stations deployed, more gravity deployed, and the article that came out today from USGS is more electrical studies deployed as well, right? And so this article from today, also on hawaiitracker.com, is talking about the MT survey. MT stands for magnetotelluric sounding. It's a passive physical technique that measures tiny perturbations in the natural Earth magnetic and electric, quote, parentheses, telluric fields to map out how well the rocks beneath our feet conduct electricity. Last year, they got high-quality data at about 40 sites within the national park. This year, they're going to return to do 65 sites, including in Puna along the East Rift Zone, and also bringing USGS Denver crew as well. So the final phase of work will occur in May to June when a Denver crew collect any remaining sites, both inside and outside the national park. So the reason they're doing this MT study is to actually try to map out the subsurface system of, it's measuring conductivity, but that's something that you can then use to try to map out the magma pathways. And what they're hoping to figure out here, let's see here, the project will cover almost the entire surface of Kilauea and allow us to see more detail about the subsurface plumbing in the Southwest Rift Zone and the Lower East Rift Zone that fed a 2018 Puna eruption. They're going to combine these with the AEM data and magnetic survey flown last year to give us a very detailed CAT scale of the volcano. So over February and May to June this year, you may see scientists installing these MT sites across Kilauea in collaboration with all these other partners: National Park, Kamehameha Schools, Bishop Estate, State of Hawaii, DLNR, OHA, Couple Whole Line Development, and all the others where the sites are located there. So just one quick follow-up. There was the original article back in May of 2022 about this MT study. And I just wanted to pull from here what this MT actually is once again. MT sounding is deploying electrodes and wire coils buried at shallow depths to passively measure the EM energy generated by lightning strikes around the equator. So that's the interesting thing. The actual energy source is lightning strikes around the equator. Lightning storms are common in equatorial regions, and these storms produce surprisingly constant EM noise that travels around the globe in the atmosphere between the Earth's surface and the ionosphere. So the response to the Earth to this distant EM stimulation can tell us about electrical properties of the Earth below the coils to depths of around 10 kilometers, 6 miles. That's the key information right there to me. So they'll be able to essentially produce a subsurface image down to 6 miles. But to do that, you need to leave the instrument in the ground for something like 5 days at least, right? So they come out and they dig a bunch of holes, they bury the instruments, they keep going, and then when they finish the one section, they'll come back and dig them back up and collect the data, sort of thing. So that's why it's being done. We don't have any data released yet, right? Here's one of the original maps of the MT sites across the entire island there. Across Kilauea in particular, right? A couple going up Mauna Loa as well here, but that is the Volcano Watch series from this week and last week a little bit as well. And so we'll finish off with talking about our community events here, starting with one that is coming up this Saturday, 2 days from now, February 4th, 10 a.m. to 2 p.m. at the Pahoa Gym, Billy Kanoi Pahoa District Park Gym. And once again, this is a County of Hawaii event that's bringing department heads and representatives to give updates to the community on restoration of roads, water, parks, Pohoiki boat ramp, wastewater studies, placemaking at Pohoiki. There are also live performances, resources there, keiki activities, free food truck vouchers, food there as well. So you can register online, and that is this coming weekend. Also going on in February, here at a national park, we had a series of events. Here's an image of Master Carver, who's putting on a demonstration. This is James Kaulukukui Jr. And his program, Learn to Carve Hawaiian Style, is next week, February 8th, 10 a.m. to noon, across from the Visitor Center at the Ohia Wing. And that's one of the events that's happening there. Prior to that, next week on Tuesday, after dark in the park, 7 p.m. as usual, is monitoring seabirds in Hawaiʻi Volcanoes National Park. The Ua'u Hawaiian petrel and Ake band-rumped storm petrel are seabirds that spend most of their life in the open ocean, coming to land. And the key here is that they have trained Hawaii detector dogs to find these bird nests. And so they actually went in 2022 and found bird nests that even the experts had never seen before because the dogs were able to sniff them out. So that's something coming up next week on Tuesday. Moving forward in time, the following Tuesday after dark is a virtual visit to Papahanaumokuakea National Marine Monument. And that is hosted by Andy Collins with the Mokupapapa Discovery Center, 7 p.m. That's Valentine's Day, Tuesday. That following day and Wednesday, unusual timing there, but Wednesday, 7, 8 p.m., same after dark timing, there is a concert by Ben Ka'ili, Hilo's own Hawaiian slide key guitarist and 3-time Na Hoku Hano Hano award winner. So that's coming up next week as well. And then the following week, Saturday, Kahuku Coffee Talk with aquatic biologist Anne Farahi, along with Park Ranger Dean Gallagher, and a virtual visit to the Ankulin pools. That's over at Kahuku. And so Kahuku has a couple of other events happening as well. So Kahuku over in the southwest rift of Mauna Loa, not far from Ocean View, has that talk story. They also have Thursday through Sunday, 8 to 4 a.m. open, and they have various walks and things there as well. We still have our friend Dick Hirschberger putting on presentations as part of the KDEN, Kilauea Drama Entertainment Network, reenacting Dr. Thomas Jagger at the edge of Kīlauea volcano, dressed in period costume. That's happening most Fridays. It happens tomorrow, the following week, the 10th, 17th, and 24th, 10 a.m. and noon, each about an hour at the Visitor Center, and the usual stewardship events as well. Now, the park did put out one last addendum to add scientist and comedian Ben Miller performing in Kahuku February 25th. There he is, from 11 a.m. to noon. And this is courtesy of the National Park Arts Foundation, who has selected comedian Ben Miller as a February artist in residence at Hawaiian Volcanoes National Park, nonprofit's first ever comedian artist. So he's a New York City-based scientist turned comedian who's entertained at top clubs, including the Broadway Comedy Club, Stand Up New York, The Stand, And as a child, had a picture in his bedroom of Mauna Loa erupting. So he will liaise with park rangers, scientists, and other residents during his month-long park residency. So Kahuku, special performance, Saturday 25th, 11 to noon, and that is the wrap-up of our community events. So Dane, I've talked for a full hour here. Maybe time to say some thank yous. I'll pass it over to you.
Yeah, just want to thank everybody that tuned out today to start that off. We rely on viewers like you to get the information out there, to help share it and get it traction in the algorithm and YouTube, Facebook, and all those. Everybody's different, but it, you being here is the main staple of the channel, right? Like, share, subscribe, all that stuff really does help with the algorithm and helps the channel grow. We had a bunch of super chatters come through. I want to recognize them as well. But first, I just want to talk a little bit about the Resilience Hubs. We've been participating in the Vibrant Hawaii Resilience Hub Makahiki festivals. We've been attending those. I think we've done something like probably 6 now, maybe more. And these events are located around the island and at the sites of the Resilience Hubs. They're hosting these events to try and familiarize people with the existence of these hubs. They're kind of a new idea, right? And we're involved in this and trying to help them with the online sphere of the whole thing. But basically, this is trying to work off of many of the ideas from 2018 and the eruption that we went through then, and what we had to do ad hoc on the fly to be able to meet the challenge and provide people with the resources necessary during that tough time. And this comes from the Pu'unu'opuna, which was the hub, that was the cornerstone of the community response in 2018. And then also the online sphere, which was more the Hawaii Tracker part of the equation, and how that all kind of goes together. And it really is trailblazing, right? And but when you're out here in Hawaii on the a place that's geologically on fast forward, you kind of need to have these more paradigm breaking projects and collaborations in order to meet the challenge that's pretty persistent and pretty unique that we encounter here. I mean, I remember when FEMA came out in 2018, FEMA was really good at being able to meet the challenges of something like a hurricane in the southern US. But when they start trying to meet a unique challenge, like you have volcanic gas being emitted under a house, and now the concrete floor is 150 degrees Fahrenheit, they're confused and it gets weird, right? And so we're trying to help all that process and create this niche that we're able to really establish, and work with and interlace it with the government efforts. So it's all one big collaboration instead of like disjointed and everybody running around doing their own things, trying to get some collaboration on the whole thing. So that's my spiel about the resilience hubs. There's going to be more talk about the digital resilience hubs coming up and that whole process. But as of right now, support the Vibrant Hawaii Resilience Hubs. If maybe look out and see if what groups are in your area, if you're on island, if this interests you, because it's really so much easier to do this stuff ahead of time before you have to do it in the disaster when you're trying to do other stuff all together. Get it all done now, get everything set up, and then when it actually happens, we're ready. So that's
for sure. Yeah,
my whole spiel is there. Go ahead.
Yeah, for sure. Yeah. The resilience hubs are super important. We did see them, coming out of Puna for sure. As they were being developed, they actually served a role during COVID as well, distributing food and supplies. So they're up to the resilience hubs version 2 now, right? Or is it version 3 actually? Or they've been expanding to all the communities. Right. So it's really about network building, right? We really want to make sure that all the people who are educated, such as you guys who are watching and active in the communities and are able to help in one way or another, that can be networked ahead of time, right? So that when the time actually comes, you're able to help at a hub or able to help online we'll be proposing digital hubs at some point as well too here, and just be involved in some way, because really what happened in 2018 that was really impressive to us, that we were really proud to be part of, was the crowdsourcing of information, right? It wasn't that we knew everything that was going on just inherently, like we were being fed information by the whole community constantly, right? And we're just able to synthesize and share that through the platform. Really, that's really where our work started here. So it's really crowdsourcing. We really need the crowd for it to be crowdsourcing, and you guys are part of that. So I just want to echo what Dane said. And if you're able to support a Vibrant Hawaii Resilience Hub in any way, please do so, and you'll be supporting us as well.
All right. Yeah, and so with talking about support, let's talk about some people that dropped some super chats. We had a bunch of people come through today, really. Our old-time supporter, long-time supporter, Gary Bryan, came through with a $40 super chat. Says, thanks, guys, for keeping the community informed. Appreciate the support there, Gary. Chris Kiki comes through with a $40. So thank you, gentlemen, for sharing your knowledge and keeping us informed. Appreciate the 40 there. We had a $100 super chat from Richard, who just threw a shaka, but he had a comment that was rather interesting when we were looking at the lava lake and those islets forming. He was saying that it looks like glacial calving, and except for it's rock and lava, right, instead of water and ice.
Yeah, absolutely.
So yeah.
Technically, ice is a rock. If you ask a geologist, because it's a mineral, and minerals are all rocks. So yeah, technically, yeah. Very, very similar. And I'll just throw in there, Richard, mahalo for your support. And yeah, we can open a whole can of worms on the whole, what you call those little floating things, because at some point we're calling them lava bergs, not unlike an iceberg. That's what you'd see calving off the glacier there. So there are a lot of connections for sure.
Right. Yep. All right. And then we had a $10 super chat from Two Feathers. Says, thanks, guys. One of my favorite things is catching you live. And then we had a $10 super chat from Two Feathers, who says, Charles made me feel guilty. Appreciate the back-to-back super chats there. Two Feathers. And yes, we had a $4.99 super chat from our recurring supporter, John Zhao, who's asked, says, I enjoy your channel, and asks, how close have volcanoes gotten to the lake?
So we have heard, I heard this at the talk the other night, in fact, that the geologists have walked up to the edge of the lake and collected samples of that first outburst of lava from early January. So they've actually landed on a down-drop block and walked to the edge of it. The surface of it, out in the middle, where it's actually more active, they haven't been there, right? They haven't collected anything fresh. They haven't collected anything from near the fountains, really. It's more that first flood that came all the way to the edge of the crater and got to where they could actually access it. Because the surface, as you guys can see, there's ooze-up flows. That ooze-up flow that we showed on a time-lapse that happened about a week ago was about the same size as a lava lake, right? So you're talking about like a 30-acre area that suddenly bursts and is all... You can't be on the ground there. Like, that's...
No.
You just can't do that. So they're coming up to the edge where they know the ground is hot and peeking at the edge. And we heard Drew Downs talk about how the helicopter lands, they get out, they take their sample, but the helicopter stays running the whole time, so that if they see that surge coming, they just run back and get in, and up they're up. So it's very, and I'm sure they also have monitors watching the cameras and signals or radioing to them if they see anything unusual happening. Like that's standard procedure at HBO.
That down-drop block being, once the lava came up and reached it, really created that access point that was needed to be able to get down there, because otherwise it was just sheer cliffs. And how are you going to get down there? You're going to rappel, but now you can have plenty of room to land that chopper and be able to walk down to the edge of the lake and collect whatever samples, and then, get out of there no problem. So yeah, that is an interesting... Something that wasn't available a year ago?
Yeah, I mean... The cliffs are definitely not as big, but I think there's still some cliffs there. I think if you actually were there in person, the cliffs that look not so big on our webcams are probably pretty hard to navigate in person. But still, they found a way to get down there, and yeah, pretty cool. Thank you guys, yes, for all you guys do.
All right. I don't really have that many questions actually lined up. Was addressing a few of them in chat.
We have one more thank you.
We want to thank Vivi Grant. So we want to thank County of Hawaii, really, for the Vivi Grant program. They've been able to enable us to do this type of content, as well as written and short videos, consistently for the next year, and that covered us for like the Mauna Loa eruption and keeps us going during the times when things aren't happening. Right when when the volcanoes are erupting and there's a ton of action, then we have a ton of traction and we have a lot of support. But it's times in between the eruptions, or when one of them's barely erupting in a steady state, that really the support and the preparation, the work to build for the next big eruption is taking place, right? That's the really important bit. Once we get to the eruption, it's really just executing all the preparation that we've had before that point. So yes, I appreciate everybody that's tuned in. I appreciate the Vai Camp. Appreciate County of Hawaii for giving us this assurance too, so we don't have to basically sell out and clickbait to get the views, and we're not doing that model, right? We just have to give the best information that we can.
Yeah, for sure. And one bonus thank you here. That's not officially official one, but one more shout out to I Care Hawaii, who had us into their office this past week, and you may see us at some point in the next few weeks here sporting some new glasses. We'll see. How the transition with that goes. But mahalo once again, you guys. Appreciate you, and great to visit you and talk story this past week.
Right. And I just wanted to, acknowledge one thing that they did that I didn't know about was all the extra examinations that they did, and the non-invasive examinations, in order to try and test for things that you wouldn't even think about during an eye exam. And this is all out of their pocket that they're doing this stuff at. And they were telling me that, some of those tests that they were doing, those extra tests, they were able to find that a 6-year-old had a tumor in his eye and caught it early type of thing. And it was an extra test that was at cost to them that was able to basically get the kid on the path towards treatment and recovery early. So hopefully they have a better, shot and all that kind of, it's not just turning a dollar there, right? They're actually trying to look out.
Yeah, great contribution to the community for sure.
Right. All right. Well, I think that gets us through everything I had for you today. We will be back next week. Our standard time is 5 p.m. Hawaii Standard Time. Unless something happens, then we'll go live. Don't really expect it, but hey, you never know. We've done it before in the middle of the night. So yes, otherwise we'll be back next Thursday. Check out HawaiiTracker.com, Hawaii Tracker Facebook group. That is where a lot of the action goes down in between these live streams. So if you're here and you want to keep up and see a bunch of really amazing photos, we have a ton of photographers that are basically world class that contribute there regularly. So definitely come check out Hawaii Tracker on the Facebook page.
For sure, yeah. I'm only curating a very, very, very small amount of stuff that's coming from there, right? So because there's just way too much. There's just too much. We'd be live all day, every day, showing everything if we did it that way. So we're trying to really keep it more focused here, but definitely that's a compliment to everything we're doing here. So definitely go check it out for sure. Appreciate it, Dane. Appreciate all our supporters online. And until next week, from HawaiiTracker.com, I'm Philip Ong. He's Dane DuPont. Aloha, everyone.